Now, let's verify here this identity using the basic identities. Verify that sine times secant is 10. In this case here, sine, can write it as sine theta times. Then you have to ask yourself, secant, using the reciprocal of secant. We know that secant of theta is 1 over, since we start here with S, so it will start with C, which is cosine. So secant is 1 over cosine. So it was sine times secant is 10. We want to verify it. Sine theta times. Now you have to replace secant with 1 over cosine. Equals 10. Then let's multiply here. Sine times 1 is sine over cosine. And we know that from this identity here, if you come back here, that's just 1 second, please. That sine over cosine is 10. So sine over cosine is 10. So we prove it. So here, as you see, we have an sine times secant is 10. We want to prove it. Sine, keep it as sine. Secant, it is 1 over cosine. Equals 10. Secant is 1 over cosine. Then if you multiply sine times 1 over cosine, you get it as sine over cosine, which is 10.
Teacher?
Yes.
Can they say secant times 1 over sine?
Secant is 1 over
Sine?
No, secant is 1 over cosine.
Yeah, can I say this one?
No. It is identity.
Yeah.
Secant is 1 over cosine, but cosecant is 1 over sine.
So we usually start with the first one.
No, according to the, how did you see? Yani if I keep it sine as 1 over cosecant, okay, and secant over cosecant, isn't an identity? Yeah, I mean like if you have it like this, you have it start with it like this, like keep sine, or keep secant as it is, and sine write it as 1 over cosecant. So what did you have now? You have secant
Over cosecant.
Okay. Then it's
not equal 10.
How did you know if it's equal 10 or no? You will simplify it. That secant is 1 over cosine, and cosecant is 1 over sine. And you know that if you have 1 or A over B over C over D, it's the same as, one, you can say like,
yeah, it will equal cosine over sine.
B times D. So it will be D over A. So I mean like here, it will be sine over cosine, which is 10. So if you keep secant as it is and you convert sine, you will verify that it's equal 10. But here you have a long question, or you can say that you have many steps to verify that, sine times secant is tan.
Yeah, so teacher, secant and cosecant, we can simplify them. But for the sine and cosine, no, we can leave them like that.
Yes, yes. Sine and cosine, like they are the basic. You cannot simplify them. You cannot convert them or rewrite them in other identity. Some cases, maybe you need it. But in the all cases, they need to write tan as tan or cotan or secant or cosecant using sine and cosine and tan. Sometimes you need to write it as sine and cosine.
Thank you.
You're welcome. Is it clear?
Yes.
Yeah. Yes, teacher.
Teacher.
Okay. Now, 1 over cotan, I want to prefer that it is tan. We said yesterday that tan is sine over cosine, and cotan is cosine over sine. So let's replace cotan with cosine over sine. That's mean here 1 over cosine, 1 divide by cosine. So it's 1 divide by cosine over sine. That's mean 1 keeps the change or convert divide to be as multiply and write the reciprocal of cosine over sine, which is sine over cosine. So, and we know that sine over cosine is tan from here. That's what you want to prove. Is it clear?
Yeah.
Yes. Yeah.
Now, this one here, cosecant over secant is cotan. Now I will give you 2 minutes. Please try to verify it in your notebook and tell me if you can or not. Then I will solve it.
Teacher, I finished.
Did you verify it?
Yeah.
Good.
Teacher, shall I send it to you the my answer?
No. Just say that you can or not.
Yeah, I can.
Alhamdulillah.
بسم الله الرحمن الرحيم. هذا أخ موفق معنا من الأردن، قاعدين إحنا في
Teacher,
Yes.
Teacher Rahat told me that her net is very low and her computer too, so she can't hear your voice very well and like that.
Okay. Yeah. Let's now verify it here. Cosecant over secant. We want to verify that it's cotan. Now, cosecant, it is 1 over sine. And secant, it's 1 over cosine. So, here they are. Divide by 1 over cosine. It means it's 1 over sine times cosine, which is cosine over sine. And we know from the tangent identity that cosine over sine is cotan, which is true. Now, let's go back now to the unit circle. Remember that in the unit circle here, we have an we have that any point in the unit circle, its coordinate is cosine and sine. So that's mean if we draw a triangle here, we said that this is x and this is y. So the x-axis is cosine and the y-axis is sine. And since this is y and this side here is parallel to y, so this will be sine. And we say that since it is a unit circle, so its radius is 1. And we remember that from our previous lessons, that if I want to write the equation of the circle, I have to say x squared minus 0, or x minus 0 squared plus y minus 0 squared equals the radius squared. Now where is x? It is cosine. And where is y? It is sine. And what is the radius of the circle here? It is 1. So using the unit circle, we verify one of the identities, which we call it by Pythagorean identity. That's if you add cosine squared of any angle plus sine squared of any angle, you get 1. This we call it Pythagorean theorem. That's mean we know before that sine of 30 is half and cosine of 30 is square root of 3 over 2. Now, this identity tell me that if you add sine squared of 30 plus cosine squared of 30, you must get 1. Sine squared of 30, it is half squared, plus square root of 3 over 2 squared. Is it equal 1? So it will be like so 1 over 4 times square root of 3 squared. It means 3 over 4, which is 4 over 4. We can simplify it as 1. So yes. So any sine square or any angle, if you square its sine and if you square its cosine and you add them, you get 1. This is here, we call it Pythagorean identity. Cosine squared plus sine squared equals 1. Now there's another identity, which is 1 plus tan squared equals secant. This one here, 1 plus tan squared of theta equal secant squared of theta. The first one
It will be
was
minus tan squared.
no. Oh, just 1 second, please. The Pythagorean identities. We have 3. The first one, 1 plus tan squared is secant. The second one, 1 over plus cosine squared is cosecant. And third one, sine squared plus cosine squared is 1. So here, sine plus cosine is 1. But the previous two, the first two, that 1 plus tan is secant. So that means secant minus tan is 1. Not like sine plus cosine. Here they are secant minus tan is 1. And cosecant minus cotan is 1. These 3 are very, very, very important. You need them in grade 10 and in grade 11 and grade 12 in calculus. Don't forget them. Now, let's come back to problem 3 here in order to verify that 1 plus tan squared is secant squared. 1 plus, now tan, we know tan is sine over cosine. So, and we know that secant is 1 over cosecant. 1 over cosine. So 1 plus tan squared. Tan squared, it is sine squared over, or let's say it is sine over cosine squared. Is it right? You replace tan with sine over cosine. Then we know that if you have as a over b squared, you can rewrite it, or you can say that this power will distribute it on the numerator and denominator. So it is a squared over b squared. Here we have the same. Just here you have to distribute it in both numerator and denominator. So we can rewrite it now as 1 plus sine squared over cosine squared. Then 1 plus sine squared over cosine squared. What is the next step? What do you have to do next?
Equal 1 over cosine.
How? No, fair, before that. Here, 1 plus sine over cosine.
We can say this is the same as tan squared.
No, okay. Well, if you say it like it's tan squared, you
But
come
repeat
back
it
to the
again.
the Pythagorean. But that's we must verify it.
We will skip the, wait. We will simplify them
How?
by skipping the tan,
How skipping the tan?
like 1 plus tan squared.
No, now forget
is
that 1 plus tan or equals secant. This is you want to prove it. You don't know it.
Like we know that sine over cosine is tan.
Okay, but you come back to your question.
Teacher, like if we say that cosine squared over cosine squared plus sine squared over cosine squared, it will be equal 1 over cosine, I think.
Can you repeat, please?
Like if we say cosine squared over cosine squared plus sine squared over cosine squared, then it will be cosine squared plus sine squared over cosine squared. Then the cosine will skip the cosine, and then it will be 1
Teacher,
over
we just need to unite the denominators, and then we say that one.
Yes.
Yeah,
Thank you,
we
Rose.
just
Here,
and then
you
it
have
will
to
become
make
it
them the
correct?
same denominator. So here, you have to multiply by cosine squared, and here you have to multiply by cosine squared. In order to write them, have the same denominator, or you can use the cross product. That's sine squared plus cosine squared, or you can, or some of the students call it butterfly way, over cosine squared. Or as I told you, you can just multiply both of the denominators by cosine. Here you have 1, so you multiply it by cosine squared by cosine squared. Then 1 times cosine is cosine plus sine squared over cosine. And we know that from this identity here, that 1 of cosine plus sine is 1 over cosine squared. And from the previous identities, we know that 1 over cosine is secant squared. Oh, I mean like 1 over cosine is secant, so 1 over cosine squared will be secant squared. Is it clear?
Yeah.
Yes, teacher. Yeah.
yeah.
And this is here the third Pythagorean theorem. That's 1 plus cotan is cosecant. Let's actually have the same steps. 1 plus. Now cotan, we know that it is cosine over sine squared. So one plus cosine over sine squared, you have to distribute the power on both the numerator and the denominator. Then here we have it as 2 fractions, or we can say 2 fractions, okay, that they can add it, but they don't have the same denominator. So let's make them have the same denominator by multiplying both sides by sine squared. Then sine squared times 1 is sine squared plus cosine squared equals over sine. Then sine plus cosine is 1 over sine squared of theta. Then 1 over sine, let's come back here, I'll write it here now. 1 over sine squared. Now we know that 1 over sine is cosecant. 1 over sine is cosecant. So 1 over sine squared will be cosecant squared. That's what did we prove now. Is it clear?
Yes, teacher.
Yes.
Yeah.
Okay. That's it. I will stop here because the period is finished. Tomorrow, inshallah, we will continue.
Thank you, teacher.
Yeah.
Thank you, teacher.